Hi folks, we're going to take a look at page 347, numbers 23E and 25C. Okay, so in 23E they give us this rectangular prism, and we got three vectors that are indicated here, and they want us to find the vector ik minus ih in terms of a, b, and c. Okay. So let's start by drawing these vectors as best as we can. So here the vector ik is just going to be this diagonal, okay, through the box, and then ih, well, is this vector along one of the edges, okay? And since we're trying to find the subtraction between them, and these two vectors are placed tail to tail, we know that the subtraction is just going to join the two tips. So we just have to figure out which direction it's going to be in. So here, remember, when we subtract vectors that are tail to tail, the vector it produces is the one that joins the tip, going from the tip of the second to the tip of the first. So it's going to be from H to K. Okay, so this is the vector we're looking for, except we want to write this vector in terms of A, B, and C. All right, and what I notice here is that this vector is going to be connected to the sides here, GH and I guess GK. All right, so let's see how we can do that. So the first thing I see here is that I can add, let's get one other color here, is if I add this vector plus that vector, I'm going to get the vector that I'm looking for, HK. What is this vector here? I see, well, it's not quite the vector B, it's the vector negative B. Okay, and then this vector here was exactly the same as the vector C. So this here is just going to be equal to negative B plus C. Okay, of course, another way of writing this, perhaps a nicer way of writing this, would be the vector C minus the vector B. All right. So what we did here is, first of all, figured out what the two vectors are that we were subtracting. Since they were placed tail to tail, we remembered that the vector that is formed by a subtraction joins the two tips, going from the tip of the second to the tip of the first. Okay, and then from there we were able to determine the sum of the vectors needed to achieve that. So in this case here, we needed negative B and we needed C, and added those two together. Okay, so that's it for this one here. So let's take a look at 25C. So they don't give us much information here, but they do tell us that the vectors A and B are perpendicular. And then they want us to write the magnitude of this combination of A and B in terms of the individual magnitudes. Okay, so I'm going to do is I'm going to draw a diagram here to help me out. So if A and B are perpendicular, well, 2A is just going to be some vector in the same direction as A, and 3B is going to be some vector in the same direction as B. So that means that these two vectors are also parallel, okay? Perpendicular. So if I write this and say this is the vector 2A, okay, and say this is the vector 3B, okay, they don't actually give us any information, but I know that these two vectors are perpendicular. Okay, so if I want to add these together, well, of course, I'm going to move them tip to tail. Okay, so I'll move that one over. Okay, but that's still going to be a perpendicular angle, and this is the sum, 2A plus 3B. So if I'm looking for the magnitude, so here, let me deal with the magnitudes of these here. But of course, the magnitude of 2A is just 2 times the magnitude of A. And the magnitude of 3B is just 3 times the magnitude of B. So if I want to determine an expression for this here, well, I can just use Pythagoras, because this is just the hypotenuse of a right angle triangle. All right, so let's write out Pythagoras here. So this side length, magnitude of 2A plus 3B, okay, is just going to be equal to the square root of the sum of the squares of the other two sides. So in other words, the square of 2 times the magnitude of A plus the square of 3 times the magnitude of B. And then when I simplify this, well, what do I get? I just get 4 times magnitude of A squared plus 9 times magnitude of B squared. And what I've managed to do is to write this expression, in other words, this magnitude, in terms of the individual magnitudes of A and B. Okay? Not the nicest thing in the world because we got this square root, but that's as simple as we can get. There's nothing further we can do to simplify this expression. Okay, so just to recap here, what I did is I realized that if A and B were perpendicular, 2A and 3B would still be perpendicular. And then I just set up my diagram and realized that 2A plus 3B just represented the hypotenuse of a right angle triangle. Okay, that's it for these.